Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is our next understanding about as a part of various case studies. Here, we are going to understand about what are the various conditions we are going to face as a ground improvement techniques, as a part of ground improvement techniques, how we are implementing the various methodologies. We have different types of methods for getting the required properties of the soil. So as a part of that, here today we are understanding the ground improvement using stone columns for bridge foundations. For bridge foundations, what kind of for bridge foundation, what kind of techniques are helpful? So what kind of requirements are there for this type of bridge construction? So these are all the things which we are going to understand in this particular topic. So how these stone columns. So in this particular case study, the background of this particular case study, we are consider this Kolkata, the project located in Kolkata in India nearby the Hooghly River. So an area which is characterized by the soft and weak alluvial soil. So according to the type of soil, here the type of soil is alluvial soil. So what are these characteristics? What type of properties involved in this? That may be whether its density, plasticity, liquid limit and plasticity limits their limits on how which state it convert into at which point it is going to convert into a plastic limit or whether it is liquid limit, how we are getting. So we are know about the all basic properties, parameters about these particular soil in that particular locality, and what type of requirements are for the construction of this bridge. For construction of bridge, what type of projects are involved in this project? According to the projects, what are the requirements? According to that, we are going to choose the method of improving technique. So according to that, we are going to understand this ground improvement techniques in this particular case study. So first we are understanding the where it is, the location. So according to the location, we are going to understand the type of soil in a particular locality, and after doing these experiments or laboratory, we are conducting the lab tests or inside test. It depends upon these scenarios. In situ test. According to that, we know about the properties of that particular soil type. We are identify the type of soil. Once we identify the type of soil, here the type of soil is alluvial soil. It is soft and weak. According to their properties, we are going to understand. And this what type of project it is also gives the clear picture about the case study. So here the construction involved the foundation of a bridge. So here the type of project it is the type of project is bridge, and according to that, what type of in that what are the various elements involved in this to this soil. So how we are going to improve these soil properties for getting the design requirements of that particular projects. So here we are concentration about that foundation. So obviously the foundation, we know about the foundation. Foundation is the underground structure. So it may involve different kinds of layers of the soils are involved. Each layer have their own kind of properties, and also groundwater levels are also involved in these such type of projects. So because it is nearby the Hooghly River, the effect is more and compared to the various sites which are far away from these kind of water ponds or rivers, water available areas when compared to the dry areas. So these kind of wet areas, the soil layers are having different kinds of characteristics because of these water table effects, and the availability of water is more. So at the time of foundation, we are going to understand in various parameters for getting the, for reducing these water effects, and it may not lead to the effect of the project in so many various parameters. We will see all these things in this particular concept. So here what we are going to do, this is the background of the case study. So in this particular point, what we understand, so according to the location, the project is located in Kolkata, that is near by the river. So according to that, we have to understand the what are the various types are involved in this, what are the elements we are going to understand. Now, based on the type of the project, in that the element foundation of the bridge. So we are going to concentrate about that foundation. What are the elements, what are the various things, design parameters involved in this foundation. We have to concentrate for understanding about the requirement of the soil. So we have to understand the what are the design parameters are involved, what kind of design we are going to choose for construction of these foundation, in that what type of material we are using. These are all the affected factors on depending upon the, otherwise depending upon the soil conditions. So here the type of project, the construction involved the foundation of a bridge which was essential for connectivity and infrastructure development. So here we will see what are the various challenges involved in this. The soil at the site consisted primarily of weak alluvial deposits which are problematic for supporting heavy structure. Bridge itself, it is a heavy structure. So in these so many heavy loads are going to move. Heavy loads are the load. The bridge itself, it is a heavy structure, and moving loads are heavy. Moving loads are there in any type of the bridge. So we have to understand those difficulties, and we are going to face those kind of challenges in this particular case study. And because of the weakness and softness of the soil, and it is also nearby the river. So consider all these soil parameters. We are going to understand it is going to be, and also it need to be support the heavy structure. So once we are understanding from this case study, this has the low bearing capacity soil. So the soil was unable, how much the numerical value we will identify conducting the test or in situ test, or so many tests are involved for understanding the each kind of property of the soil. So according to the property, we are going to choose the which type of test is required for knowing about the property of the soil. So based on that, for just for understanding, so it is a weak soil, we will understand because it is nearby river, and that it is characterization is also mentioned. So that's why so understanding is according to that. So we want exact values, means we are going to conduct tests only. So then only we will get the exact numerical values of that particular soil properties, whether it is density, what are the various properties involved in that. We want to know about the saturation and permeability. These are all the parameters we are going to understand. Strength, soil strength. So these are we may understand using the laboratory tests. So in this low bearing capacity, once we understand these parameter, the soil was unable to support the imposed loads. So of the bridge piers without significant settlement. So here there is a chance of settlement because of the weakness and soft soil it is. So it means it ultimately lead to the affect the construction work. And also this is the one of the challenge we are going to face in this particular scenario. And One more thing, that is high settlement potential. Because of this soft compressible soil posed a risk for the both total settlement and also the differential settlement. It may not only that the settlement may not be equal. So because of the nature of the soil, because of the what kind of type of bridge construction we are doing, so heavy loads, heavy machineries we are using. At the time of construction also we are using heavy different types of machineries for completion of the construction work, and using type of material, we are using for steel bridges, or otherwise for construction of these foundation, those piers are having lot of concrete and everything. So for carrying all these materials from here to there, somewhere to location of the project, so these are all the parameters may cause these kind of settlements. So we have to understand in total settlement as well as the differential settlement. So potential comparison the stability and integrity of the bridge over the time. So from over the time to time, how much it is going to settle. So once the heavy loads are there, how it is settles. We are not able to impose how much bridge total heavy load into at a time. It is difficult to us. So that's why we have analyzing, we done the analyzation. After that, then only we are going to understand and we are implementing these ground improvement techniques for this particular case study. So here, these are the major challenges what we observe from the knowing about the location and the type of the soil. So these are the major challenges we are facing, that is the soil at this site consists primarily of a weak alluvial deposits which are problematic for the supporting heavy structures. For supporting heavy structures for these weak alluvial deposits is one of the challenge. According to that, we are going to choose the ground improvement technique. Why we are choose that location only? Why we can't go for another location? Because of this it may cost is more, and so many problematic and so many challenges are there, but the location has their own priority in terms of social growth of the country, economical growth, development point of view. So population demand is there. So according to the population and according to the public interest, we have to construct there only. That may be the one of the reason, and few also more added for that. So that practical things are pushing us to do the work at that particular location only. So no need to change. So at the time of designing, at the time of decision making, whenever they are consider these kind of scenarios, so at that time only we have to think all these parameters. So it depends upon the practical scenarios. So, and the one more important challenge, that is the low bearing capacity. The soil was unable to support these imposed loads of the bridge piers without significant settlements. So we have to concentrate on this challenge. We are going to reduce, and also we are going to, the soil must be stable to support these imposed loads of the bridge piers without significant effect. Using the required ground improvement technique method we have to choose. And also high settlement potential, because of the soft compressible soil posed a risk for these both the settlements, whether that is maybe total settlements in times, or in some of the scenarios it may be the differential settlement. That potential comparing thing, we will need the stability and integrity of the bridge over the time. For getting the stability and integrity of this bridge over the time, based on the soil, we have to improve few more properties of the soil using the ground improvement techniques. So like that, this is the background of the case study, how we are going to understand what are the various parameters involved in this particular case study. Now, what is the importance of these ground improvement techniques? Still in previous slide, what we understand, what are the various parameters are involved in this particular case study, and what type of ground improvement is required. As a civil engineer, we have to dealing with these kind of soft and weak soil conditions. For there only we require these ground improvement techniques. So in this, it is a technique used to enhancing these engineering soil properties. So according to the requirement of the project, here the requirement of the project is foundation of a bridge in types of bridge point of view. So before that, choosing the ground improvement, we have to understand the what type of project we are dealing, along that the based on the soil type, and what are the challenges involved in that. According to that, we are going to choose the method of the ground improvement technique, which the choosing of this ground improvement technique depends upon the ground improvement technique. So here it is a technique we use it to enhance the engineering properties. So as per this particular case study, we understand the soil type is, it is soft as well as weak soil. So and low bearing capacity, and also it requires more stability and integrity, and also the various settlements are happening. So the settlement, the risk of settlement is to be reduced. Is need to reduce. These are all the parameters which are involved in this particular case study. So here the ground improvement, the choosing of the method. So we have different types of methods based on the mechanical modifications if we required for soil. We have different types are available. Dewatering, so many traditional methods and advanced methods are involved, and also for chemical modification, physical modification. According to each type of modification, hydraulic modification, it depends upon the different variety, different types of methods are there. So based on the project type and the type of the soil, we are going to choose that particular method gives in its best, gives the results in terms of the sustain. What are the challenges they are going to reduce, and they are going to convert. We are not going to face those kind of challenges after the construction. So like that we are going to choose. It plays a very crucial role and very important role in this ground improvement technique in this such type of the soil conditions. So here for projects like bridge construction, so ensuring the stability of foundation is a very important parameter. So without improvement, as it is the soil is there, we are not done with any kind of ground improvement. So we are facing so many challenges as well as so many hurdles, and it may risk so many in so many parameters in economical point of view and also safety point of view. These are the the failures are going to be very uncomfortable conditions. So here for those kind of projects like bridge construction, ensuring the stability of foundation is very important. Otherwise we are facing so many different practical scenarios we may understand, and without these improvements, structures built on these weak soil, we are going to build these soil, the risk of excessive settlement leading to the potential structural failures. Leading to structural failure is a very worst scenario of any civil engineer. So that's why we have to, it's plays the ground improvement techniques. So the ground improvements plays a very crucial role in these type of scenarios. And also this stability, the foundation stability or stability of foundations is a key preventing the long-term issues such as cracks in structure, uneven settlement, and increased maintenance costs. So according to that, the importance of the crucial things. So based on that, we are going to choose the ground improvement technique. It plays a very important role in this. So because of these, foundation safety is a key for the long term issues. We are going to prevent the long term issues by using suitable ground improvement technique that reduces the and preventing the long term issues such as cracks in the structure, uneven settlement, and increased maintenance costs. So these are the parameters are involved in this ground improvement scenario, this particular case study. So importance of these ground improvement techniques for civil engineering point of view, it's a crucial because all we are dealing with the soil conditions in, they are not favorable, they are unfavorable. Whenever the scenarios are unfavorable, we are working on those. So that's why we have to understand the soil properties and the type of construction. According to that, we are going to choose type of ground improvement suitable as per the requirement. So like that, we are going to understand these. Now, why here in this particular case study, we are that ground improvement technique is stone columns. So here we choose for this, that is equal to stone columns. Why stone columns? We have n different number of ground improvement techniques are there. Why we are choose these stone columns? Stone columns are the most effective ground improvement techniques used to stabilize the soft soils. So here we are dealing with soft soils and also we require the foundation stability, that is foundation stability, and also to prevent the settlement also. So these are the challenges we are going to face. For this is the one of the best solutions we choose, that is the ground improvement technique is we choose this ground improvement technique for this particular case study is the stone columns. So because of the it is used to stabilize the soft soils. So once we go through this, already in previous lectures we know about how the stone columns are working, what is the principle involved in that, various situations where we are using these type of stone columns, how they are effectively implemented, the implementation, the advantages, the whole process we will see in our previous lectures. Now we have a quick overview about that. So stone columns involve drilling into weak soils. First, we are going to these stone columns involves drilling into the weak soil and filling the holes with compacted stone aggregates. So here the stone columns involve the drilling. So here into weak soils and filling the holes with compacted stone aggregates. So these aggregates are also in different scenarios we are going to understand. The size of the aggregate and also the strength of the aggregate. So what kind of material we are choosing for these are all the parameters we have to understand for choosing these kind of technique for getting the required or desired properties of the soil. So in this stone columns involved, so because of these, whenever we are choosing these compacted stone aggregates to form vertical columns, these columns improve the soil strength and support the structural loads. So in foundations, whenever these type of foundations are to be involved in these weak type of soils, these kind of stone columns, so stone columns gives these improved soil strength. So in weak soils and soft soils, the soil strength is less and whenever they are supporting these structural loads, the settlement is going to happen. For preventing that, we choose this stone column, we are drilling, and as per the designed, once we design these as per the scenarios, as per the properties of the soil, how much enhancement is required for that soil, enhanced properties. Based on the enhanced properties, we are choosing these stone aggregates. And the depth of the drilling, these are the parameters which are involved based on the properties of the soil. So in this, these columns improve the soil strength based on the aggregates which we choose, and the depth also we are going to choose is depends upon the weakness of the soil. Weak soil or soft soil, how much there till that, and also they based on the nearby water tables also. These are all we are considered. So in this, so from form to vertical columns. So we are form like these stone columns as vertical columns. Form as like vertical columns. These columns improve the soil strength and support the structural loads. Support these structural loads. So according to these stone columns, what we understand from this particular case study, so because of the soft nature of the soil, so we are using these stone columns as a vertical columns, and they are going to support the whatever the heavy loads, and there for these bridge loads, all the loads those are coming from these bridge structure. It is going to consider as a foundation. These vertical columns gives the strength. And in this also, the cost effectiveness compared to the deeper and more complex foundation solutions like piles. So we made different types of methods are also there. So whenever we are compared to the deeper and more complex foundation solution like piles, these stone columns provides a more economical solution for improving the soft soils. So in soft soil properties point of view, soft soils properties point of view, we are going to consider it is economical one when compared to the ground improvement techniques we choose for these piles. So for this pile foundation having more not economical when compared to these kind of the soft soils for the desired improvement of the properties of the soft soil. So in this improved, we know we increased the soil strength, it means it increased the bearing capacity also. So that improvement in soil bearing capacity, stone column helps to significantly enhance the load bearing capacity of the weak soils by transferring the loads from the structure to deeper, more stable soil layers. It creates that more stable soil layers. So these are the advantages. That's why we choose these stone columns, because of the stabilize the soil, soft soils, and also their compacted stone aggregates to form vertical columns, improve soil strength and support structural loads, and also it is cost effectiveness, and also significantly enhance the load bearing capacity of these soft soils or weak soils by transferring the loads from the structures to deeper, more stable soil layers. And so in this, few more advantages we will understand, that is reduction in settlement. By reinforcing the soil, stone columns are reduced both total and differential settlement. So we understand in previous slides, because of the soft soils of the present location where we consider this particular case study for the bridge foundations. Here we are getting the total and also the differential settlements, differential settlements. We observe these conditions. So for helping out, these stone columns are going to consider one more advantage, that is reduction in settlement. So by enforcing the soil, stone columns are reduced both these total settlement and also the differential settlement, helping to ensure the bridge foundation remains stable over the time. This is considered one of the challenges. In this scenario, in this particular case study, we consider it is as a one of the challenges. So we are going to overcome this challenge from this stone column, and also adaptability to the different soil conditions. Stone columns can be used in various types of soils. We may choose these technique. Not only the adaptability of this soil condition is soft, but this adaptability nature is there for these stone columns. Ground improvement technique, that is stone column, has also we may use the different soil conditions. So we may use these various soils. Those are including clay, silt and sand, making them versatile for a wide range of geotechnical conditions. So each type of soft, clay, sand, each type of soil has their own kind of soil properties. They are not very same. For these, each has their own kind of challenges. For all these stone columns, ground improvement techniques is suitable. They also help in accelerating the consolidation process, and also the consolidation process also, the stone column technique is helpful in soft clayey soils by providing these vertical drainage paths. So these are the various advantages involved in this stone column. That's why we choose this stone column technique. So this introduction sets the stage for this explaining about this lecture. So here we understand the background of the case study. In this, the project is located in Kolkata, India, nearby this Hubli river. The characteristics of the soil is soft and weak alluvial soils. So the type of projects involved, that is the foundation of the bridge. So as per the type of the soil, we are facing some of the challenges. So according to the challenges, why the ground improvement technique is important in various parameter characteristics point of view, we choose this ground improvement technique, that is equal to stone column. And what are the advantages involved in this? So here why we choose this quick overview, already the detailed explanation about the stone columns, how we install, all these are there in our previous lectures. And now we understand in terms of quick overview point of view, and also what are the advantages involved over the other type of ground improvement techniques as similar like stone column. But for the conditions are there for choosing, this is the best method based on the challenges. So as per the challenges, we are getting the advantages using this stone column. These are the things we will see in this. Now understand these alluvial soil. So because of then only what type of soil we are choosing, what type of stone column technique we choose, how much depth. So these are all we will understand only about this composition of alluvial soil. So in this, silt, sand, clay are involved. So fine grained particles. So here the silt, the composition, silt. So it is a fine grained particles, typically smaller than sand but larger than clay. So silt means fine grained particles. They are smaller than the sand and but larger than the clay. So silt is to prone high compressibility. They are going to. So now we are understanding those properties of the soil in theoretical point of view. And poor drainage characteristics. So they are not going to prevent the drainage. So whenever water it is there, it is going to flow, erode, or they are not going to. In so many challenges, we are going to understand on which way it is getting the water, or otherwise the water table is available, how it is react. So here the silt, it is a fine grained particle, typically smaller than the sand but larger than the clay. Silt is prone to high compressibility. It is a high compressibility soil and also poor drainage characteristics. In sand, coarser than the silt. It is somewhat coarse than this sand. It is not a coarse aggregate. It is somewhat better than the silt. And sand particles provide some drainage but are oftenly loosely packaged, which results in lower load bearing capacity. So here those are lower bearing capacity. Coming to the clay, it is very fine particles with high water retention capacity. So here there is no, here somewhat, here high water retention capacity. Clay soils in alluvial deposits can exhibit high plasticity. The nature is high plasticity and are particularly susceptible to settlement when subjected to load. Because of all these properties, we are going to facing those challenges. Those are low bearing capacity, low bearing capacity of soil, and they are not stable, stability is less, and also the settlement is happened. Settlement issues, these we are facing because of these properties are there in this soil. So these are all soils are often stratified, meaning different layers of sand, silt and clay are present, making their behavior more complex when subjected to loads. So whenever we are applying loads, because of these high compressibility and also the poor drainage characteristics and also the plasticity nature, gives the more complex situations. So more complex because of the load conditions whenever we are applying the loads. So these kind of composition is involved in this alluvial soil. So in this, what kind of problems we are observing? Those are low shear strength. It means alluvial soil typically have low shear strength because of the high plasticity, meaning the lack of ability to resist the shear stress, making them unsuitable when subjected to the large structural loads. In this particular case study, we are talking about the bridges. So these bridges are so many different types of loads are involved. Those are all heavy structural loads. So, and one more important thing, that is this shear strength is critical for preventing sliding or failure of soil under load, and in weak soils the risk of shear failure is high because of the depending upon the shear strength. Here, because of the type of the soil having the low shear strength. So in this property, in these characteristics, for preventing sliding or failure of soil under load, and in weak the risk of shear failure is high. These are the problems which we are going to understand in this alluvial soils because of the softness. Here also these are the things we are going to understand: high plasticity, high compressibility and low shear strength causes the shear failure is high. These are the problems which we are going to understand. Because of this high compressibility, compressibility refers to the ability of soil to deform under load. So compressibility is nothing but the deform under load. So the compressibility, high compressibility, it is going to highly deform, and alluvial soil is highly compressible, especially in their silt and clayey layers. This can lead to the significant settlement. Because of the low shear strength, the shear failure is higher. Because of the high compressibility, the significant settlement is there. Whether the significant settlements may be in total settlement or differential settlement. So these high compressibility, these solve the problem. So suspectability to the differential settlements occurs when different parts of a structure settle unevenly, causing structural deformation, cracking, and potential failure. So the variable nature of alluvial deposits with alternating layers of the sand, silt, clay makes them particularly prone to uneven settlement. This is especially problematic for bridge foundation where uniform distribution is critical. So we require this uniform distribution in type of this. It is very critical in these particular scenarios. Now, what are the engineering properties of these alluvial soil? Moisture content. Here, alluvial soils, particularly the clay and silt portion, tend to retain significant amount of the water. They are going to retain the significant amount of the water. It means high moisture content. They are going to adopt these content. So retain significant amount of water. It means it has high moisture content, reduces the soil strength and increase its compressibility. The presence of groundwater and the soil's ability to retain water can result in soft, weak soil layers that lack the necessary stiffness for supporting heavy loads. These drainage problems are also arise due to the fine-grained nature of the silt slate because of they are retaining the amount. So this nature of silt and clay making it harder for water to escape, which further weakness to the soil. It adds that. So the drainage problems also we are facing. In this bulk density, it is nothing but the mass per unit volume of alluvial soils is generally low due to the loose arrangement of the soil particles, particularly in sandy and silty layers. The loose packing of soil particle results in low relative density, contributing to weak load bearing capacity. Field density tests in Kolkata region often show values that are significant to directly support heavy structures like bridge foundation without additional ground improvement. So coming to the bearing capacity refers to the maximum load that the soil can safely support without undergoing the shear failures. In alluvial deposits, the bearing capacity is typically low, often into the range of 20 to 30 kPa in natural conditions, especially in silty and clayey layers. Such low bearing capacity cannot support the heavy loads exerted by the bridge foundation, necessitating the soil reinforcement or other ground improvement measures. And compressibility. It refers to the amount of settlement of soil undergoes when subjected to load. High compressibility in these type of soils results the excessive settlement. The soft clay and silt layers in Kolkata are highly compressible, meaning that without intervention, a bridge built on these soils would experience significant settlement over the time. So this settlement can lead to the long-term instability and the potential for foundation failure if not properly addressed. So without ground improvement techniques, we are going to face all these foundation failures and also we experience the settlements and also the amount of settlements we are going to understand in this compressibility. So necessity of these ground improvement techniques in structural limitations of these alluvial soil because of the silt, clay and sand layers are there in this. The adaptability of the water and also the drainage conditions, it is highly compressible, high plasticity. So because of these given combination of the low bearing capacity, high compressibility and the potential differential settlement, the natural state of the alluvial soils in Kolkata is unsuitable for direct foundation construction without ground improvement technique. Without ground improvement technique, it is the natural state, it is unsuitable. So here the scenarios are unsuitable without ground improvement technique for the direct foundation construction. So a bridge construction is directly on such soils without ground improvement would experience the excessive settlement over the time, which could lead to the misalignment of the structure and also cracking and also eventual failure. So in these unsuitable conditions, that excessive settlement, it may lead to the cracks and structural failure. So that's why we have to choose these. That's why it is necessity for choosing these ground improvement techniques. So this need for ground improvement is essential to enhance the soil properties. So here we are going to enhance the soil properties so that the soil can support the weight of the bridge without excessive deformation. By increasing the bearing capacity and reducing settlement, ground improvement ensures the long-term stability of the structures. It requires the stability and improved soil properties. So by increasing the bearing capacity and reducing settlement, ground improvement ensure the long-term stability of the structures. So in stone columns are particularly effective solutions in this case. They improve the load bearing capacity and also reduces, because we choose these stone columns. So improve in terms of all these parameters and also the bearing capacity and also the bearing capacity and reduce the settlement, enhance the drainage characteristics. So this technique allows for the safe and stable construction of heavy structures like bridge foundation and otherwise unsuitable soils. So these are all the ground improvements we need. We choose, that's why the ground improvement technique for this condition is stone columns. So in this stone column technique, basic concept of this column definition, those are vertical inclusions of compacted granular material, crushed stone or granule inserted into the ground to improve weak soils. So here the function involved in this is the load transfer. Stone columns transfer the loads from the structure to the deeper, more stable soil layers. In drainage, stone columns facilitate drainage, reducing the excessive pore water pressure and accelerating the soil consolidation and also the consolidation. So this is the basic concepts and their functions involved in these stone columns. Here, based on the design parameters, it involves the construction method, installation techniques we are going to follow. These stone columns are design parameters. It depends upon the spacing and diameter of the stone columns, typically between 0.6 to 1 meter. The depth of the installation based on the soil stratigraphy and load requirements. This column layout, regular grid or triangular arrangement based on the load distribution. Here these are the construction methods and these are the steps involved in this stone column. That is, the one is drilling a hole into the ground using a vibroflate and also placing gravel in next step. That is, we are going to placing the gravel or crushed stone into the hole in the stages. And one more step what we are considering, that is in the compacting the stone using vibratory equipment to form dense columns. So repeat the process at designed in intervals across the foundation area. So the installation technique we are going to choose vibro placement, dry method and wet method. So a vibro placement is used to displace the soil and compact the stone. So typically used in granular soils where is no water is required during the installation. Used in cohesive soils where water jet assists in drilling and compaction. It depends upon the installation techniques. So in this advantage of these stone columns, that is increased bearing capacity, accelerated consolidation and reduced settlement, relatively quick and cost effective compared to the deep foundation solutions, applicable in wide range of soils, especially cohesive and silt soils. In these stone columns also have their own limitation. Those are effectiveness is reduced in very soft or highly organic soils, requires specialized equipment and skilled operators, may not be suitable for soils with high fines content as drainage can be restricted. In the overall project point of view location, these geotechnical challenges what we observe, those are weak alluvial deposits with low bearing capacity in the range of 20 to 30 kilopascals, high settlement potential due to the compressible nature of the soil, necessity to ensure the stability for heavy loads from the bridge structure, and design stone columns for this Kolkata bridge column layout. Columns were arranged in grid pattern, the bridge foundation to ensure even load distribution, spacing typically between 2 meters from center to center. So the stone columns 0.8 to 1 meter were used, extended to the depths around 12 to 15 meters. In this soil improvement objectives, increase bearing capacities to support bridge piers, reduce total and differential settlement to acceptable limits, improve drainage properties of the soil. These are the project overview. And also the implementation process. So boreholes, logs and in situ testings, where standard penetration test and cone penetration test were performed to assess the soil properties. So these ground conditions were monitored as this influences the choice of the wet or dry installation methods. In this construction, a vibro float was used to install the stone columns by displacing the alluvial soil and compacting the stone aggregates in stages. The quality control was maintained by checking the vertically columns and ensure adequate compaction of the stone. These monitoring and verification, settlement plates and load tests were conducted to verify the improvement in soil properties, and also results showed significant improvement in soil bearing capacity and reduced settlement rates. So in this, overall performance of these bridge foundation improved bearing capacity. So here the bearing capacity of the soil increased to over 150 kPa, sufficient to support the bridges design loads. Settlement reduction. Total settlement was reduced to within the allowable limits and differential settlement was minimal, preventing the structural issues. The long-term stability, the use of stone columns ensured the long-term performance of the bridge without no significant maintenance issues reported due to the foundation settlements. These are the overall view about this particular case study. We will see next case study in our next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.